Okay, today we're going to be talking about the chi-square test for relationships again. Except today, what we're going to be focusing on is the stuff for a single population, which is really important. And what you might recall from the last lesson is we talked about a chi-square test for homogeneity. That's when we had multiple populations. So like when we were talking about the superpowers, one of the populations came from the UK and one came from the US, two separate populations, and that's when you use the chi-square test for homogeneity. Today, when we talk about single populations, what we're going to be talking about is the chi-square test of association. I believe also sometimes called independence, but you can use the phrase association. So that, again, is when you're talking about one population. Okay, so back from chapter 5, we were talking about relationships between gender and allergies for a simple random sample of 40 students who completed a survey. And here's a two-way table. And what we're going to do is we're going to talk about the conditional probabilities to verify this information. So we have two different parts here. We have the female students, and we have the male students. And we are talking about their allergies and no allergies. And if we look at the female students with allergies, that's 10 out of the 23 females. Which as a decimal we do 0.435. And then the female with no allergies are the remaining, the 13 out of the 23, which is 0.565. And for the males, it was 8 out of 17, which is 0.471. And the remaining, of course, then would be 9 out of 17, which is 0.529. These are called the conditional distributions. And so we're supposed to find out, to verify if this is true. So what we're asking is, really, is the probability that you have allergies given that you're female, is this equal to the probability that you have allergies given that you're male? Are those the same thing? And so we find out the probability of having allergies given that you're a female is 0.435. And we want to know, is this equal to the probability of having allergies given that you're a male, which is 0.471. And we can definitely see that this is not true. So what does that tell you if they're not the same? They are not independent. These are not independent. So that's what that shows you. If those two conditional probabilities are not true, then they're not independent. All right, so the next thing that we're going to talk about is making a well-labeled graph, talking about these conditional distributions. And so I guess we could do something like the following. And we could do maybe female, male, and then down here would be the proportions. And we know that they have to be a total of 1 when we finish. So here would be 0.5, not negative 5. 1, 2, 3, 4, 6, 7, 8, 9. And there are two parts, so I probably should use a key. And let's see, maybe orange would be allergies. And purple would be no allergies. And so for the females, if we're talking about the females stuff, we know that of course they have to go all the way to 100%. for allergies and not allergies. And if we talk about the females' allergies, we said the females' allergies was 43%. So I just shade into 43, so here's 4, 3, maybe right about there. So here are the females' allergies. And then the no allergies, of course, would be the rest. And we can do the same thing for the males. This is just a visual of what's going on. And the male allergies were 47, roughly. And then the no allergies, of course, would be the remainder. And that's all they're looking for there. Questions about that? Maybe important to say? You can say it either way, I think. Doesn't really matter. So maybe, well, let's say it Sam's way, because he answered. So the proportion of allergies is lower for females than males. This may suggest that there is an association between gender and allergies. Maybe. Maybe not. Okay, so on our next page, the page you love to see, the page that we are not going to spend much time on. The only thing I'm going to point out again is today we are talking about the chi-square test for association. Sometimes you could use the phrase independence if you want to. I think if you put the slash is great, then you're the superstar. But I think if you say association, you're going to be fine. Again, the reason that we're doing this is that there is a single population. Whereas when we did the superpowers, we were talking about the US and the UK, there were two populations. So we're still using our four-step process. We're going to do a test, which means we have a null hypothesis and an alternative hypothesis. Make sure you define those when you plan. Don't forget the random sample. And when you're doing these tables, it's the large sample size. You're going to say that all the counts are at least 5 and show it. For independence, you're going to say that your population is 10 times the sample, show it, and then, for, of course, state your test that you're doing, and we just got done saying that we're talking about the chi-square test of association and independence. In the doing part, same as the past, we need to find the expected counts, which is the row times the column divided by the table total. Chi-square is the same as it was in the previous lesson, and then we find our p-value, and we draw our conclusion. Your degrees of freedom are going to be the same as the degrees of freedom before. It's the column minus 1 times the row minus 1. And then draw your conclusion in the end as we have in the past. Always assume alpha at 0.05 and say it if they don't give it to you. On our next page, we're actually going to do one. So here we are back to the allergies thing. And now we're actually going to do something. Notice how they talk about a test at the 5% significance level. What does that tell me? Alpha, 0.05. Okay, so no big deal. We start out by saying our null hypothesis. So our null hypothesis is that there is no association between gender and having allergies for high school students in the U.S. who filled out, yeah, why not? The, what was it called? The census? Something or other? The survey. I'm just going to go with the survey. The census at school survey. Remember, you always want to put these in the context. The reader wants to see that because they love reading and writing. And then your alternative hypothesis is the exact same thing, except you're going to say there is an association dot dot dot. Okay, so for right now, I'll put the dot dot dot, no big deal. When you take your test here, and when you take it for the AP exam, don't do the dot dot dot. In order to do the next part, when I'm actually doing like the, actually I don't need to, I suppose, yeah, I can do it later. All right, so let's talk about what we're gonna do next. We will do a chi-square test for association / independence. Done with that. We have a random sample of 40 high school students. So I got that. We assume there are more than 400 students so since, bless you, our population is greater than or equal to 10 times our sample, independence is shown, bless you. And in order to find out whether or not we have our normality, we have to see the large sample size. So when we look at the large sample size, I'm going to do this in a different color so it's easier to see. So let's check the large sample size. And that's with when our expected counts and what that is. So we take our marginal distributions and calculate that. So for our expected counts, we have females and males, and we had allergies and no allergies in our table. And so for the females with allergies, that would have been 10.35. For the males, it was 7.65. For the no allergies females, it was 12.65 and 9.35. And this is the same way we calculated them last time in our table, where you take the probability or the distribution, total marginal distributions, and you multiply by what you would expect. And we notice that all counts are greater than or equal to 5. Then we move on to find our math stuff.